Hi, I'm Nick Van Gordon.
And I'm Ryan Suits.
And I'm Nick Sizik.
And we think math is cool!
There's more to learn from this experience other than that Ryan just sucks at basketball. We can use calculus for fun. If you ever thought that calculus could only be applicable in the classroom, you would be wrong.
After some calculations, we found this graph which depicts the vertical distance of the ball over time. We started the timer when the ball first hit the ground.
When the ball reached its highest point at the top of the backboard, we calculated its time and the height of where it was.
We found that the ball's highest point was 146 inches or 3.7 meters.
When the ball hit the ground and returned to a height of 0, we stopped the timer and found the total time that it took to be 1.6 seconds.
We found the instantaneous rate of change at 1/3 t, which came out to be 8/15. We used the equation y2 minus y1 over x2 minus x1. When we plugged in 8/15 into the equation, we came out with y2 being 3.28889 minus y1 being 3.2889094 over 8/15 minus a little bit more than 8/15, which was 0.53334, which all came out to be 3.075, which we ended up rounding to 3.08. In the second part, we used the same equation, y2 minus y1 over x2 minus x1. We got y2 being 3.28889 minus y1 being 3.2888478, all divided by 8/15 minus a little bit less than 8/15, which was 0.5332, which all came out to be 3.0825, which we rounded to 3.08. Altogether, we got the answer was 3.08.
We found the average rate of change on the interval 0 to 1/3 of our total time, which came out to be 8/15 of a second. To find the average rate of change, we did y2 minus y1 over x2 minus x1, which was, when I plugged in 8/15 into our equation, 3.2888889 minus 0 over 8/15 minus 0, which came out to approximately 6.17.
The point where an object changes direction is equal to where the first derivative of an equation equals 0. So we took the first derivative of our equation of our curve and got negative 11.5625t plus 9.25. So we set this equation equal to 0 and then solved algebraically for t, and we were able to find that the point where an object changes direction in our situation was 0.8 seconds.
We found the change of the change on our graph at 1/4 of the total time. To do this, we first found the first derivative, which equaled negative 11.5625t plus 9.25. Then we found the second derivative, which is equal to the change of the change, and that equaled negative 11.5625. And that was a constant across the whole graph, so no matter where the time was, it would always equal negative 11.5625.
The last thing we calculated was the total displacement and the total distance that our ball traveled during this project. We found that the total displacement was 0 because the ball started on the ground, and at the end of it, it also was on the ground. We also found that the total distance that the ball traveled was 7.4 meters. This is because at the top of its travel, it traveled up 3.7 meters, and then it traveled back down another 3.7 meters to make its total distance 7.4 meters.
Thanks for watching our video.
I hope you enjoyed it.